Confidence interval for population proportion using the standard normal tables. We revisit example 1 from the previous video, which was titled Margin of Error, in which from a sample of 600 shoppers, 33% chose brand A. We want to use the standard normal tables to obtain a more accurate expression for the 95% confidence interval for the proportion of shoppers who chose brand A. So in the previous example, we used the empirical rule to work out this question. And the empirical rule states that for a 95% confidence interval, the margin of error equals 1 over root n. But we're not going to use this time because we want a more accurate expression. So in order to get a more accurate expression for a confidence interval, we use the standard normal tables. So step 1. First of all, p hat is equal to 0.33. So again, we got that from the question. And we want to obtain a 95% confidence interval for p. And our n is going to be equal to 600. So this information we got from the question. Step 2. We need to calculate the standard error of the proportion. And the formula for that is square root p hat times 1 minus p hat divided by n. So this is given in our formula book, except it usually has p in place of p hat. But since p is not available, only p hat is, we're going to have to use p hat. So we have the square root of 0.33, which is p hat, times 1 minus 0.33 divided by 600, which is our n, the number of our sample. And into the calculator, we get the standard error of the proportion to be 0.019196. Step 3. We now need to find the z value for the appropriate value of c, the confidence level, i.e. we want to find the value of z such that the probability that z is greater or equal to minus z, less than or equal to z is equal to c. And in this case, c is equal to 0.95 because we're interested in a 95% confidence interval. So, if p being the probability, if the probability that z is greater or equal to minus z, less than or equal to z is 0.95, then from the diagram, we get the probability that z is less or equal to z to be equal to 0.95 plus 0.025, which is 0.975. So if from here to here is 0.95, then 1 minus 0.95 equals 0.05. So the leftover tail on either end adds to 0.05. And dividing that by 2, we get 0.025. So the area underneath the right tail from z to the end of the tail is 0.025, and the area underneath the left tail is also 0.025. So if we're interested, the probability that z is less than or equal to z, which is this point here, we want the area of everywhere to the left of it. So from here to here is 0.95, and from here to here is 0.025. So all together, we have 0.975. And from the standard normal tables, z is equal to 1.96. So we're going to have a look at where this came from now in a minute. So we search through our tables until we find 0.975, and we see that it corresponds to 1.9 and 0.06, and 1.9 plus 0.06 is 1.96. So z is equal to 1.96. So step 4. Z is the number of standard deviations, or the standard error, that the margin of error is from the mean. Thus, the margin of error E is given by E equal to Z times the standard error, which is E equal to 1.96, which we got in the previous slide, times 0.019196, which gives us 0.03762. So this is our margin of error. Step 5. The 95% confidence interval for the true proportion P is then P hat minus E, the margin of error, P hat plus E, the margin of error. So again, P hat is 0.33 minus the new margin of error, which is 0.03762, and 0.03 plus 0.03762. So subtracting, we get 0.29238, and adding, we get 0.36762. So P, the true proportion of the population, lies between 29.2% and 36.8%. i.e., the true proportion with 95% confidence lies between 29.238% and 36.762%. So we are 95% confident that the true proportion lies somewhere between these percentages. So we get a very close answer to what we got in example 1 in the previous video, but this is much more accurate because we've used the standard normal tables, whereas previously we used the empirical rule, and we used the fact that E can be equal to 1 over root n when we're dealing with a 95% confidence interval. Note that this interval is more restricted than the approximate interval obtained by using the 1 over root n formula for E, but it is far more accurate. We can use the same method to find a 99% confidence interval for the proportion of shoppers who chose brand A. The key differences lies in the calculation of Z. We find that the probability that Z is between minus Z and Z equal to 0.99 leads to the probability that Z is less than or equal to Z equal to 0.995, because 0.99 plus half of 0.01 is 0.995. And searching through the tables for this, we get the corresponding Z value to be 2.575. Then the margin of error E is Z, which is 2.575, multiplied by the standard error, which is the same, which is 0.019196, and multiplying we get 0.04943. So this is the margin of error for a 99% confidence interval. So notice that the standard error remains the same. Thus, the 99% confidence interval is, again, P hat minus the margin of error, which is 0.33 minus 0.04943, and P hat plus the margin of error, which is 0.33 plus 0.04943, which gives us 0.28057 and 0.37943. i.e., the true proportion with 99% confidence lies between 28.057% and 37.943%. So notice that this interval is wider than the interval for 95%. So in the previous slide for 95% confidence interval, we got P to be between 0.29 approximately and 0.36. So we notice that as our confidence level increases, our interval widens. You should note that increasing the confidence level from 95% to 99% causes the confidence interval to widen. This is generally true. So confidence intervals using the standard normal tables. Suppose the sample size of n gives a proportion p hat for a certain characteristic. Then the true proportion p, step 1, we have the standard error of the proportion, which is square root p hat 1 minus p hat all over n. Step 2, the margin of error for C% confidence level will be the margin of error is equal to Z multiplied by the standard error of the proportion, where the value of Z depends on C, and specifically for 95% confidence, Z is equal to 1.96. Be a good idea to learn this off as this is the most common. And step 3, the confidence interval. So P, the true proportion, lies between P hat minus the margin of error and P hat plus the margin of error. In a survey of 450 voters, 180 say that they intend to vote yes in a forthcoming referendum. Part 1. By using Z tables, the standard normal tables, determine a 95% confidence interval. So let P be the population proportion, then P hat, which is the sample proportion, will be 180 divided by 450, which is 0.4. So 180 said they intend to vote yes, and the total number surveyed was 450. So 180 over 450 is 0.4, which is P hat, or you could say 40%. Next, we're going to substitute into our formula for the standard error. So we have the square root of P hat times 1 minus P hat over n. So we have the square root of 0.4 times 1 minus 0.4 over 450. So since we're interested in a 95% confidence interval, we're going to use Z to be equal to 1.96. So E, the margin of error, will be Z, which is 1.96, multiplied by the standard error, which is 0.0231, which gives us 0.0453. So we got that from this formula here. E, the margin of error, is equal to Z multiplied by the standard error of the proportion. Thus, the 95% confidence interval for P is P greater than P hat minus E and P less than P hat plus E. So P hat minus E is 0.4 minus 0.0453, which gives us 0.3547. And P hat plus E, 0.4 plus 0.0453, gives 0.4453. So P, the true proportion of the population, lies between this and this. Or, as percentages, we can be 95% confident that the true proportion lies between 35.47% and 44.53%. Part 2. Describe how a 98% confidence interval would compare with the interval in Part 1. A 98% confidence interval would be centered on P hat equals 0.4, but would be wider, have a greater margin of error than the 95% confidence interval.